So the videos for 9-6 are broken into two parts. You should have already watched the 9-6 video that shows these first 4 examples on the front side. However, it did not include the 2 examples on the back. So this video will cover these 2 examples. And these examples are situations where you have more than 2 inequalities in the same system to solve graphically. I'm actually going to start with the bottom example. It's a little more simple for a couple of reasons. So we're going to start down here and graph these 3 inequalities. I'm going to start with y is less than or equal to 3. And I'm going to graph that one in blue. Y equals 3 is just a horizontal line through 3. Since it's less than or equal to, it's going to be a solid line. So I draw a solid line through y equals 3. And then remember, we want to use a test point to decide if I'm going to shade above or below. Test 0, 0. Is 0 less than or equal to 3? Yes. So this one I would shade below. Okay. So it's no different than what you did on the front. The problem is you're just going to do it 3 times. So my next equation is, graph in red, y is greater than or equal to, so it's going to be solid again, -1/2 x plus 2. This one's in slope-intercept form, so I'm going to graph my y-intercept at 2. And then it's got a -1/2 slope, so I go down 1 over 2. And I'm going to keep doing that until I end the grid. And then I'm going to go up 1, back 2 as well. Now usually I'd be able to stop right there because this is the point of intersection on that line. However, because I have a third one to graph, I'm going to keep going. Once again, it was greater than or equal to, so it's going to be solid. So I do a solid line through those points. And last but not least, I once again can use my test point of 0, 0. I ask myself, is 0 greater than or equal to, this goes away, 2, and no, it is not, which means for the red line, I shade this way. Now the last piece that comes up in this is there's actually a third inequality. So I'll graph that one in green. And this one is x is less than or equal to 4. So x equals something is a vertical line. So I'm going to go to 4 on the x-axis and draw a vertical line through there. It's less than or equal to, so once again it's going to be a solid vertical line. I once again can use my favorite test point of 0, 0. I ask myself, is 0 less than or equal to 4? Yes, it is, which means I shade over it. So for the green, I shade to the left. Now remember though, what I'm looking for is where all 3 of those shadings overlap, and it would be one of these sections. You see I have all these sections on the outside, like 1, 2, 3, 4, 5, 6, 7, and then I've got this 8th section right in the middle, and it is that triangle in the middle where they all overlap. I'm going to pick a new color. Again, you would just do it pretty shaded in, but this little triangle here is actually my final solution to this system of inequalities. Now it does say what are the ordered pairs at the corners of the solution. So since this triangle is my solution, this ordered pair is one of them. That was at -2, +3. So -2, 3 is one of my points of intersection. This will become important tomorrow. This ordered pair is another corner of that triangle. It's at 4, 3. So that's a second one. And finally, 4, 0 was the third point of intersection that created that triangle. So when you have 3 inequalities in one system, you still graph each linear inequality kind of on its own, but then you're looking for where all 3 shadings overlap. That's the big difference. I'll quickly finish up by doing the one at the top. This one gets a little messier. It's a little bit of a tighter squeeze. And then the other big thing you'll see is that the first and third one are both in standard form. Because we want to have exact points, I'm actually going to convert them into slope-intercept form. So I'm going to take this one first. 2x minus 3y is less than 12. Subtract 2x, I get -3y is less than -2x plus 12. Don't forget to divide all 3 parts by a -3. So I get y I divided by a negative, so I also have to flip my symbol. Negative divided by a negative is +2/3 x, and a positive divided by a negative is negative. So that's the same as y is greater than 2/3 x minus 4. Slope-intercept form, plot my y-intercept, and now I'm going to rise 2, run 3. Rise 2, run 3, 2, run 3. I can also go down and back. Those are my points on that line. Now it's just greater than, so this one needs to be a dotted line or a dashed line. And then finally I can use my favorite point, is 0 greater than, this will go away, -4. Yes, 0 is greater than -4, so for this one I would shade everything up here. Switch colors. For my red line, I'm going to graph this one. That one's nice because it's already in slope-intercept form. So I'm going to plot a point at -5. And then my slope, there isn't one, so it means it's 1. So I rise 1, run 1. This one's going to be a critical point potentially. But I keep graphing points because I know that I will also need to graph a third system, or third inequality in the same picture. This was greater than or equal to, so this one is a solid line. So I draw that. I can use my test point as 0, 0. I ask myself, is 0 greater than or equal to -5? Yes, it is. So for my red line, I also shade above it. Last but not least, I'm going to switch colors again here. Graph my third one in green, but that one once again is in standard form. So I'm going to subtract the 3x. I get -2y is less than or equal to -3x plus 18. Once again, I'm dividing all three pieces by -2. It's an inequality that I divided by a negative, so I need to flip my symbol. Y is greater than +3/2 x minus 9. Plot my y-intercept at -9. Rise 3, run 2. So this is a point of intersection, as is this one. Okay, so those are my green dots. It's greater than or equal to, so this line is once again solid. And last but not least, use my test point of 0, 0. Is 0 greater than or equal to -9? Yes. So this one also shades this way. However, we do need to make sure that for our solution, we look at where they all overlap. And I can see that above the blue line right here, but then it switches to above the red and then above the green. Because of the way these intersect, it actually follows those, but it has a shape that kind of goes along the blue, switches along the red, and then ends along the green like that, which means that these 2 points are the points that I care about for my point of intersection. The first one is this one, where the blue intersected the red, which looks like it's at 1, 2, 3, -2. So we have 3, -2 is one of them. And then the other one was here, where the red intersected the green. 5, 6, 7, 8, 3, it looks like. Okay, so those 2 points. So this was 8, 3, and this one was 3, -2. As I said, this one was a little bit messier, but you can kind of see how it works. I think the one in your homework is more like the second one, or kind of a cross between the two. Hopefully that helps understanding how to graph a system of 3 equations.